Hello. Welcome to the first lesson of 6.4.1 Numerical Expressions. Today you are going to be continuing your knowledge of order of operations, but we're going to be adding in the exponents. So the learning target is I can simplify numerical expressions involving exponents. And remember, we are going to be using order of operations. So this first part, you can add order of operations. Don't forget your name and the date. So this next part is really just about how you can write repeated addition as multiplication. So we could do 4 plus 4 plus 4 plus 4 plus 4, but we learned in elementary school that repeated addition can be written as multiplication. Multiplication. So I believe there are 9 fours. 1, 2, 3, 4, 5, 6, 7, 8, 9. So instead of doing 4 plus 4 9 times, we can do 4 times 9, which is 36. So both of those equal 36. So for this next one, we could do 9 plus 9 plus 9 plus 9 plus 9 to get our answer. But the faster way, the more efficient way, is 9 times 5, which is 45. So similarly, if you have repeated multiplication, we can write it as or using exponents. So 2 times 2 times 2 times 2, we could do 2 times 2 is 4 times 2 is 8 times 2 is 16. Or we can say 2 to the 4th. So expanded exponential form is a shortcut that says shortcut or not. Shortcut way of writing repeated multiplication, where the expanded form is written as a product, and I'll give you an example for all of these, written as a product. And standard form is our simplified answer or number. So an example, I think I'm going to write in purple. An example would be if we had, let's say, 3, 2, I'm just going to keep with 2 to the 4th. That's the exponential form. The expanded form is written as a product or multiplication problem. So 2 times 2 times 2 times 2. And standard form is when we actually simplify. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So you're going to be going back and forth practicing between exponential and expanded form and standard form. All right, so Yes, it says choose numbers and find the value of each. So x to the third means x times x times x, where 3x means 3 times x. So if we choose x as 1, let's just do an easy one. X to the third means 1 to the third, which is 1 times 1 times 1, which is 1, where 3x means 3 times 1, which is 3. So if the 3 is an exponent, it means you're taking that factor that many times. Or if 3 is the coefficient, if it's in front, then you multiply to get the number. So just like y squared means y times y, or 2, oh, this is supposed to be a y, sorry. 2 times y. So if you choose the number, any number but 2 in this case, so if we use y is 3, this would mean 3 squared, which is 3 times 3, which is 9. But 2y means 2 times y, which is 6. Oops, 2 times 3, which is 6. So you see there are two very different things. So you're going to be just practicing going back and forth between these. So tomorrow we can add in the rest of our order of operations. So a to the third, it says to write it as an expanded form. So what it means, and your standard form once you're simplified, because these are all in exponential form right now. So this means 8 to the third. So the 3 tells us that there are 3 factors. This dot, by the way, means multiplication. The factors are, this is called the base. So the base is 8. That tells us what our factor is. So that is in exponential or expanded form. So over off to the side, I want you to write 8 to the third, and we are going to just define. So this is the exponent, this is the base, so the big number is the base, the small number is the exponent. The exponent tells us how many factors there are, and the base tells us what number each factor is. Exponent, base. So how I like to do this is I see that this is, oh, and by the way, you can use a calculator to get the expanded form. So you could do 8 times 8 times 8, or there is an exponential button. So it sometimes looks like x to the y, or it looks like a caret like this. So we would put in 8 caret 3, or you could just do 8 times 8 times 8. So 8 times 8 is 64, and then we'd have to multiply that by 8 to get this number right here. So please take a moment to do that. All right, the next one, the 6, my exponent tells us how many factors there are. So I like to write out my lines. Number times a number 6 times. 1, 2, 3, 4, 5, 6. And then the base, this, so this is the base. Oh. This is the base. And this is the exponent. So I should be color coding. So I know that I have my 6 blanks, and my base tells us what each factor is. So I'm going to have 10 times 10 times 10 times 10 times 10 times 10. And yes, you can use a calculator. So you could write 10 caret top 6 and what that equals. Or you can do 10 times 10 times 10 times 10 times 10. But sometimes if we do it that way, we lose track of how many times we put 10 in. So I know that this is, so 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000, times another 10. So 10s are easy. 1, 2, 3, 4, 5, 6. So it would be 1 million. So 10 to the 6 is 1 million. All right, sometimes you're going to have letters though. And so we can't write in standard form if it's a letter unless we know. So if you have a variable, you can't write it in standard form unless you know what the letter or variable stands for. So in this case, we can only write G times G times G times G. That's in expanded form. So expanded form, expanded form, expanded form, expanded form. If I was doing this video over again, I would have already changed colors in between to color code for you. But we can't write it in standard form. As simplified as it gets is in exponential form. So we can't write it in standard form. All right, 2/3 times 2. I know, don't be afraid. It is a fraction, I know, but in expanded form, it's just 2/3 times, because our exponent is 2, so we have 2 blanks. Our base is 2/3, 2/3, and then you're just going to multiply across for our standard form. Standard form, again, is just the number. Just the number. Whoa, my iPad just fell. Just the number. So just the number, 2 times 2 is 4, 3 times 3 is 9. All right, now we're going to go backwards. Now we're writing each in exponential form. So we're going backwards. So our base is what the factors are. Our base is what the factors are. So there's 1, 2, 3, 4, 5 5s, but my base is going to be that 5. And my exponent is going to be how many there are. So it's 5 to the 1, 2, 3, 4, 5. In this case, they're both 5s, but know where each number comes from. All right, there's supposed to be a dot or a X in between there. So in exponential form, my base is what the factors are. So each of my factors is 8. So 8 is going to be my base. And how many are there? That's going to be my exponent. There's 1, 2, 3. Okay, so we have our base. What each factor is 1/2. So that's going to be my base. And there is 1, 2, 3 of them. So my exponent is going to be 3. It's really important, though, that you put this in parentheses, though. So we know that this whole thing, 1/2, is our base. And we're raising it to the 3rd power. And lastly, just going through each, if we wrote 7/10 squared, 7/10 squared. This should be a squared in all 3 forms. So 7/10 looks like this or like this. So we are going to square it. Square is, we should talk about that. Squared is raised to the second power. So exponent of 2. Cubed is an exponent of 3. So we have our base because it says write this squared. So 7/10 squared, remember we're going to put our parentheses, squared. But here you can just use squared. So if it's a fraction, use parentheses. Expanded, remember, means written as multiplication. So exponential using an exponent. Exponent. Expanded as multiplication, or what it means. So 7/10 times 7/10, or 0.7 times 0.7. Because the base is our number, and the exponent tells us how many there are. Standard form is actually doing the answer or simplified number. Oh gosh, this is over 10 minutes. Sorry, guys. So 7 times 7 is 49. 100 times 100 is, 10 times 10 is 100. 0.7 times 0.7 is 0.49. All right, sorry this was so long. Peace out.